Hi there, I'm Mrs. Kemp and welcome to today's lesson all about immunity and vaccination. This fits into defences against pathogens, human immunity and vaccination topic. So let's get started then. Our main learning outcome for today is I can describe what a vaccine is and how a vaccination works to create immunity. We'll be using lots of new key terms today and they're on the board here for you. If you want to pause it and have a read of it further, then please do. Otherwise, rest assured that I will be going through each one of these as we move through the learning cycles. So we have two learning cycles for today. We've got immunity and how a vaccine works. Of course, we'll be starting with immunity. Okay, so let's start by thinking about why sometimes we may get a disease and then actually later on we don't catch it again. Things like chickenpox, you may have had chickenpox when you were younger. You can see on the image there, it's where you get those little spots that appear kind of all over your body. And once you've had it in childhood, you rarely get it again. There are cases where people do, but most of the time we don't. So why is that? Okay, now that's actually because your body can have a long-lasting immunity to the pathogen after the first infection. Once you've seen it once, then you've been exposed to what we call antigens. Antigens are proteins that we find on the surface of all cells. Ones that we find on pathogens actually create an immune response in your own body, and that generates your immunity. Now, the first time that we're infected then with the pathogen, our white blood cells that we're going to call lymphocytes actually produce antibodies. Antibodies are also proteins and they have a complementary structure that is specific to the shape of the antigen. You can see there that at the end of the fork of the Y on the antibody, that little binding site actually has a complementary shape to the antigen that we find on the surface of the pathogen. Each white blood cell actually only produces one specific type of antibody. Therefore, they only work on one specific type of pathogen. It takes a few days in order for antibodies to be produced and reach a level that can actually destroy the pathogens. And so therefore, in that period of time, when you've first been exposed to an antigen, it takes a little bit of time and so you may feel poorly. All right, so when you've got a cough or a cold or a temperature, that is because at that point, your body is not ready to destroy that pathogen that's in your body. The antibodies have an important job where actually they clump together those pathogens that are circulating in your body. And then we've got another type of white blood cells, so it's the lymphocytes that produce the antibodies, but we've also got these phagocytes. And phagocytes, what their job is to carry out something called phagocytosis. This is where they change their shape by putting out their cytoplasm and get hold of the pathogens, engulf them and then digest them. This will kill the pathogen. It's much faster if those pathogens are clumped together, so it's easier for them to catch them. So some of the lymphocytes that have responded to that pathogen, and that antigen, will remain in the blood as something called memory cells. Now, memory cells last for a lot longer than any of your other type of white blood cell. And therefore, if you then come in contact with that pathogen again, your immune response can be much faster to when we didn't have the memory cells. This means that next time we don't actually feel poorly. All right, so taking that example that we used a moment ago with chickenpox, the first time you get chickenpox, okay, it takes a while for you to produce the right number of antibodies to get rid of it, and therefore you feel poorly and you have those spots, you have a high temperature. The second time that you are exposed to that chickenpox virus, then actually you've already got memory cells in your blood. They reproduce rapidly, start producing the antibodies, and you can get rid of it without having any spots, any signs or symptoms of chickenpox. Okay, on to our first check then. White blood cells produce antigens against pathogens. Is that true or is that false? Can you justify your answer? Antigens clump bacteria together so they can be engulfed by phagocytes. B. Antibodies are produced in response to antigens. I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, did you think false? Well done. And that is because the antibodies produced in response to the antigens. Excellent, well done. Okay, let's have a little look at this graph then. All right, so this is antibody production after the first exposure to an antigen. This is known as your primary response. On the x-axis, we have the number of days, and on the y-axis, we have the concentration of antibodies in the blood. So here is our first infection, all right, this point at 0 on the graph. And you can see that we have a steady increase in the number of antibodies, which then plateaus and starts to decrease after that, because the antibodies in your blood, after they've been used, and if there's no more pathogen around, then actually what will happen is they will break down. Okay, so they will come out of your blood. They won't remain in your blood forever. If after the infection then with a new pathogen, the antibody production is slow at first and the person is likely to develop those symptoms of the infection. So because it is quite slow, that's when we're going to feel a little bit poorly, whatever infection it is. If it was a cold, then you might be sneezing, you might have high temperature in that time. If we have a look afterwards then, the antibody concentration isn't falling completely to 0. All right, we have still got some of those in there. Eventually, if we left it a much longer time, then that could fall to 0. But in this particular instance, it's not long enough and there's still some in there. Memory cells, though, will also stay in the blood, and that's what's really important for long-lasting immunity. And we say that the person is now immune or has immunity to that pathogen. So if we get a reinfection, there it is, the second exposure to the antigen, then you can see that my graph has spiked much higher, okay, and much faster, all right? The gradient is much steeper, so therefore the antibody production is greater, and also it's just reaching much higher levels. This means that actually you're not going to feel poorly because you are able to quickly fight off that pathogen and it hasn't got any time to cause damage in your body. So, antibody production after the first and second exposure to the antigen. The immune response in the second exposure is very fast and strong. This makes sure that the pathogen is completely cleared from your body before it can cause symptoms. The person is unlikely to feel ill. This isn't always the case for every type of disease, but it is mostly what happens. On to our next check then. Which type of blood cell remains in the blood and provides immunity? A, the memory cell. B, phagocyte. C, red blood cell. I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, did you realise that it's the memory cell? Excellent, well done. On to our first task of the day then, we're going to need our graph, and actually if you open up your worksheets, you can record your answers on there. So can you use the graph to explain why a person rarely gets chickenpox twice? I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, did you get that the initial exposure to the chickenpox antigen leads to a slow antibody production? The person is likely to feel unwell in this time. Specific memory cells remain in the blood. The person is now immune to the chickenpox. After the second exposure to chickenpox antigen, the memory cells divide rapidly to produce antibodies faster and to a higher concentration. This clears the chickenpox pathogen from the body quickly before it can cause symptoms. The person is unlikely to feel ill. I hope you got all of those points down. Please feel free to add a few more onto your answer. Excellent, well done. Okay, On to our second learning cycle of today, how a vaccine works. So, a vaccine can give a person immunity to a pathogen without them having the disease. Remember, immunity means that you actually do not show any signs or symptoms from that disease when infected. So, a vaccine is usually administered by an injection, and this is the vaccination process. You've probably been through the vaccination process, maybe when you were a baby, so you don't remember, or actually whilst you've been at school, you may have also received some vaccinations. Most of the time they are an injection, sometimes they can be inhaled or drops on your tongue. So there are different ways of vaccinating people. A vaccine contains a dead or inactive form of the pathogen, or sometimes just parts of it, so just parts of the antigen. Just like if you had been infected with the real pathogen, the body responds to the antigen. So it then produces white blood cells, and those white blood cells are the lymphocytes. Those lymphocytes, they make antibodies that are complementary to the pathogen's antigen. We can see again there that that antibody has got, at the end of its little Y, it's got that complementary structure to the antigen, and they fit together. A different type of white blood cell, just like if you've been infected with the real pathogen, will then come and clear away those parts of the vaccination. So be it the dead or inactive form of the pathogen, or just parts of it. So this is the phagocyte, and the phagocyte goes along and it changes the shape of its cytoplasm in order to engulf that packet of pathogen, and then it releases enzymes into it so it can digest and destroy that pathogen. Just like when you've been infected really, then the memory cells are then produced in order to defend against that particular antigen. This creates long-lasting immunity to that particular pathogen. So even though you haven't been exposed to the real one, you have been exposed to the antigen, and so you've created memory cells that remember how to defend your body against it. On to another check then. Who has the best explanation for how a vaccine works? Is it Yun? A pathogen is injected into a person's arm. The vaccine contains memory cells and makes the person immune. Or is it Andeep? A dead or inactive pathogen is injected into the person's arm. They make memory cells and become immune. I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, did you realise that it's Andeep? Excellent, really well done. Okay, so the immunity from a vaccination can last a long time. The MMR vaccine actually provides immunity against measles, mumps and rubella. Most of the people in your school have probably been vaccinated against MMR. It's a really important one because actually the diseases, measles, mumps and rubella, are really, really serious, especially in children. You usually need 2 doses, okay, so you have one at first and then you wait a period of time and have another one to make sure that you have enough memory cells to last. That will actually then give you protection for at least 20 years against those different diseases. So well into your adulthood, protecting you in that very precarious time during childhood. However, some pathogens such as influenza are actually able to mutate regularly, okay, and so new strains emerge all the time. Mostly year on year, we have different strains of influenza. So this makes creating a vaccine actually quite difficult. The body does not have the correct memory cells that can produce a specific complementary antibodies to the mutated pathogens' antigens. And so this means that even though you may have had a flu vaccine last year, the new strain of influenza you're not actually immune to, okay? And because of that then, it may mean that you need to have another vaccine. All right, a person vaccinated against the original pathogen may not have immunity to the mutated pathogen. In these cases then, such as influenza, a new vaccine is needed to be made and then administered. The NHS recommends that actually vulnerable people, such as the elderly, or people that have got asthma, for example, are actually encouraged to get the flu vaccine every year. So they will have a new top up with the new type of pathogen that has those new antigens, and this will be year on year, so annual vaccines, all right, and they will make sure that you are protected each year as you move into the season where you mostly see that disease. Influenza, it tends to be during those winter months when people really come down with that type of disease, so you would be expected to get that vaccine kind of in the autumn time to make sure that you're covered. Okay, can you match the word to the definition? The words are antibody, antigen, and pathogen. The definitions: a microorganism that causes disease, a molecule on the surface of a pathogen or other cell that initiates an immune response, proteins produced by white blood cells against specific pathogens. I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, shall we go through those answers then? We've got antibody goes to proteins produced by white blood cells against specific pathogens. Antigen goes to a molecule on the surface of a pathogen or other cell that initiates an immune response. Pathogen, a microorganism that causes disease. Excellent, well done. Okay, on to our final task of the day then. This one is task B. Again, you probably need your worksheet for this one, so please get that out now. I'd like you to complete the comic strip to show how a vaccine works. Write an explanation under each box. So you can see that I've got some images there that can help you to think about what you're going to put in your comic strip, and also be thinking about those key terms that we've talked about, like phagocyte, antibody, antigen, and lymphocytes. I'll give you a moment to think about it, but if you need more time, please pause the video. Okay, shall we have a look then? So the first one is showing a vaccine is given, usually an injection. The vaccine contains a dead or inactive form of the pathogen. Our next box is white blood cells. Okay, you may have written lymphocytes here because this is a more technical term. Make antibodies specific for the pathogen's antigens. A phagocyte destroys the dead or inactive form of the pathogen. That's our other type of white blood cell there. And finally, memory cells remain in the blood. The person now has immunity to the pathogen from the vaccine. So I hope you've got all of those down, but do feel free to write any extra into your boxes now. So we have come to the end of this lesson, and this has been a really great one. Lots of new information in this lesson, and I've really enjoyed teaching it. I'm just going to go through those key learning points with us to finish off. So after exposure to a pathogen, memory cells remain in the body to provide immunity. A vaccine contains a dead or inactive form of a pathogen. After vaccination, white blood cells produce specific complementary antibodies to antigens on the surface of the pathogen in the vaccine. Phagocytes engulf and digest the pathogen. Memory cells remain in the body and provide immunity. If the person is reinfected with the pathogen, the memory cells reproduce rapidly and produce lots of antibodies. There's lots of key terms in this lesson, isn't there? And some of them sound very, very similar. So it's worth making sure and going over those in the future just to check your understanding. I hope to see you again soon. Thank you. Bye.